record this in case anybody's not in the call. So notes page 144, we're looking at the angle between vectors, and for that, to do questions where you're asked to calculate angles, you are still going to be using the scalar product. I'm just going to scroll down a wee bit and show you that this here is what it looks like. I don't know if you've looked at any exam papers that are at the front of them, but this is what you see on the formula list for the scalar product. You get the A dot B equals magnitude A magnitude B cos theta, where theta is the angle between the vectors. Now the questions that we've done so far, you've been given the angle, you've possibly had to work out the magnitude, but you've been able to work out this dot product, this A dot B. Or if you've been given it in component form, you know how to multiply the x's together, multiply the y's, multiply the z, and then you're adding it all together and you get a single value. But these formulae, or this one here, right, this can be rearranged, and it's the rearranged form that you're seeing up at the top of this page here. Right, so this cos theta equals A dot B over magnitude A magnitude B. I know they've got it with a component form at the top here, but I'm more interested in this version here. But that isn't given on the formula list, and you have to know how to rearrange this. So basically, you've got cos theta here. To rearrange it, you would have to divide by the magnitude A magnitude of B to isolate the cos theta. So that part of it you will need to remember how to do. So if you get a question like this, and this is the first example on your pages, calculate the angle between these two vectors, and you go to the formula list, right, you need to be able to remember that if it's the angle you want to find, then you will rearrange it to have the cos theta on its own will be equal to A dot B over the magnitude of A and the magnitude of B. Now, when you're doing this, obviously this is P's and Q's that we're using. So we're going to be doing P dot Q rather than A dot B, and so on. So we know that we're going to have to do the dot product. Now I would first of all interpret those, because you've been given them in terms of I, J and K, I would interpret those in terms of their components. So obviously turning it into a column vector, 3, 4, minus 2 for P, Q would therefore be 4, 1 and 3. Now to be able to work out the cos of the angle, and then if we've got a value for the cos of the angle, we'll be able to get to the actual angle size. But we'll need to do the dot product, and we'll also need to work out the magnitude. Now it's better if you do that before you try and sub into the cos theta formula. So the dot product, first of all, you would be doing 3, 4, minus 2 dotted with 4, 1, 3, and that of course that gives you 3 times 4 plus your 4 times 1 plus negative 2 times 3. If you work all of that out, then you end up, right, you get 12 plus 4 and minus 6 going on there. So 12 plus 4 minus 6, that's going to give you 10. So your value for your P dot Q is 10. You then also will need to work out what the magnitude of your P and Q is equal to. So magnitude of P will be the square root of each of these components, 3 squared plus 4 squared plus negative 2 squared. Make sure you put brackets round your negative numbers when you're squaring them. All of that comes to square root of 29. You leave it as the square root of 29, don't write it as a decimal. You do the same thing for the magnitude of Q. And again, right, square root of 4 squared plus 1 squared plus 3 squared. Make sure the square root covers all of that, and that's going to be square root of 26. So you don't write decimals there for those. If they don't work out exactly, you leave them as they are. So we're going to do P dot Q, not P dot Q, we're going to do cos theta equals P dot Q on the top of your fraction. So you will have, right, cos theta, and you need to write out the formula in terms of the letters that you've got going on. So P dot Q over magnitude P magnitude of Q, and this is it down here. Save me writing all that out again. You can copy that out. You've got, sub in your values in, you get 10 over root 29 root 26, and because it's the angle that we want to be working out, you then need to take the minus 1. Now to say, so don't work out this 10 over root 29 times root 26 as a value, you just go to the calculator. Make sure you write in cos to the minus 1, and then you've got your brackets round that, and you can use your fraction key to do that, and you can check on your calculator. Make sure you're on degrees, and you round in your answer probably to 1 or 2 decimal places, and that would be it. Any questions? Okay, so everybody's okay with what we've done so far? So this is still using the dot product, so let's just have a wee quick recap on what we did in this question. So if you're going to work out the angle, you are going to have to take the dot product of the two vectors, and you need the magnitude of the two vectors. So as a matter of course, you should do that first. Work out the dot product, work out the magnitude of each, and then write down your formula. So in this case, in terms of P's and Q's, right, that was going to be that. Your theta, remember, is the angle between these two vectors, and you sub in, and then you work your way through it, and you remember that at this point here, you then want to get the theta on its own, the angle, you're going to take cos to the minus 1. Okay, so that's the first question. Second question, you're given 3 points, K, L and M, and you are asked to find K, angle K, L, M. Now, I'm going to just do a little diagram with 2 lines in it, and I'm going to say, if you're trying to find angle K, L, M, and the angle therefore in here, we'll put our theta in there. What vectors do you think I'm going to take the dot product of? When you were introduced to the scalar product or the dot product, a very important rule, and this is in your back in your notes actually, that when you take the dot product, you need to be going away from the point. If I was in class, I would be showing you this and saying you need to be pointing away, like your hands would point away from you. So the dot product that we're going to be taking is the vector L to K and L to M. Right, not L to K and ML. It matters what order you write these things down. So actually here, right, when we rearrange this, then I'll just remind you, right, your cos theta equals A dot B over magnitude A magnitude B. However, here, right, our A and B are these two vectors, L to K. So what we're actually going to do, and you need to write this down, right, is that we are working out cos theta will be equal to the dot product of L to K, and put your arrow above that, dotted with L to M, and put your arrow above that, all over the magnitude of L to K, and put your arrow above that, and the magnitude of LM, and put your arrow above that. So that's the formula that we're going to substitute into in order to work out the angle. So I'm going to do each of these bits separately. I need to be able to do the dot product. However, before I get anywhere, I first of all need to actually work out what L to K is, because I only know the coordinates. So your routine for your standard result for working out L to K is going to be K minus L. So that is going to be 1 minus 7, 2, minus, you're going to have minus 3, 3, 4, and that is equal to, right, that's going to be 4 minus 10 and then minus 2. So that's what L to K is. And then we need to work out L to M. So our L to M will be M minus L, and that will be equal to, your M is 251 minus your your L rather is minus 334, and that is equal to 52 minus 3. So we needed to work out, that's an extra bit that we needed to work out. Sometimes in an exam question, they might ask you to work out those sort of things first. They'll direct you to that, and then it might say hence. So this kind of question here, right, which has got K is the point, L is the point, M is the point, and then it's asking you to find the angle. That would, in an exam question, that would be broken up into probably tell you to find these two components first to work out L to K, L to M, and then part B would be hence find the angle KLM. So we know to find the angle we're going to have to do the dot product of these two things, and then we're also going to have to find the magnitude of each of them as well. So we're going to do the dot product. So our dot product is L to K dotted with L to M. So that means I'm doing the dot product with 4 minus 10, 2, dotted with 5, 2 minus 3. And of course that means you're doing 4 times 5 plus negative 10 times 2 plus 2 times negative 3. And if you do all that, you're going to get 20 minus 20 minus 6, and that gives you your dot product of minus 6.
Decimal positive 6.
Have I missed a minus out somewhere? I have, haven't I? 4 minus 10 minus 2. It is positive 6, but that's because I missed out my minus 2. Thank you. Right, so we would have here plus minus 2 times minus 3, which would be plus 6. So thank you, Cal, for keeping me right. And that would therefore be our final answer. Right, would be 6, not final answer, but our answer for the dot product. You then separately work out the magnitude of each of these, and a lot of this can be done like calculator work as well, but you do need to make sure you would write down your working and so on, just in case you make any errors, so that you can get the credit for it. So 4 squared plus negative 10 squared. As I say, make sure you use brackets when you're squaring on the calculator. Very, very important to put brackets around your square numbers. If you do that, that one comes to square root 120. And then separately the magnitude of LM. And we get square root of 5 squared plus 2 squared plus negative 3 squared. And that is square root 38. So these three values are what you need to be able to substitute in. So we need that 6, we need that 120, and we need that root 38. So going back up here where I've written the formula down on the right. Now it's very important that you actually interpret there is a mark for this line here, and not have it written in terms of A's and B's. It needs to be in terms of the vector that we are using. So we need that because that's one of the marks, right? So you must put the formula in, right? That must be stated in this form, and then you sub in. So we get cos theta equals 6 over root 120 times root 38, and then of course we go to the calculator. So we do theta will be equal to cos minus 1 of 6 over root 120 times root 38, and if you do all of that, hopefully it comes to who's got an answer. Waiting on somebody to give me their answer. Nobody worked that out yet?
84.9024 rounded 84.90.
Is that Hannah?
Yeah.
Thank you. That's brilliant. Yep, that's correct. So 84.90 would be our answer for that. Okay, so any questions about that? So the key thing, sometimes a diagram will help you with this sort of thing. Remember, if you're trying to find an angle between two vectors, the vectors, when you take the dot product, the vectors need to be pointing away. That must be the direction you're doing. Okay, last example. Right, so you've got a three-dimensional shape here. We've got a cube, and they're giving you the coordinates of 1.4, but because they tell you it's a cube, you can fairly quickly work out, I'm sure, the coordinates for the points T and U. So your point T, if you're looking at that diagram, which is on this face here, you're not going any along the way. So for T, you're simply going nothing in the X direction, but you'd be going 4 in the Y and then up 4. And then your U would be 4, 4 and 4. So that's interpreting a three-dimensional diagram from that. Now the next bit is just that this is more like what an exam question would do. It'd say find the components for RT and RU, and then it asks you to calculate this angle TRU. So your RT would of course be position vector of T minus R. Your T you've just worked out would be 0, 4, 4 minus the coordinates for R, where 4, 0, 0. So we end up with RT being equal to negative 4, 4, 4. And then, so that's part B. Then you're also working out RU. So R to U would be U minus R, which would be 4, 4, 4. Minus your R would be 4, 0, 0. You subtract all of that, you get 0, 4, 4. And then part C is going and work out the angle TRU. Now if you're finding the angle TRU, you need to make sure that you're doing, it's a wee diagram just to help you, remind you, right, an angle of TRU. So TRU, that's where your theta is going. The vectors that you're taking the dot product of will be R to T and R to U, and that's the ones that they've just asked you to work out. So you know you're going to have to work out the dot product for R to T, right, dotted with R to U. So that is going to be minus 4, 4. Right, dotted with your RU 0, 4, 4. So minus 4 times 0 plus 4 times 4 plus 4 times 4. So that all comes to 32. And then you separately need to work out your magnitude for r to t will be square root negative 4 squared plus 4 squared plus 4 squared. So you end up with square root of 48. And then your other one, RU. So square root of 0 squared plus 4 squared plus 4 squared. So root 32. And we can write down the formula that we would be using to work out that angle, or you can just write down the cos. You can use the lettering for your angle. Right, cos of TRU will be equal to, and it's important that you write this bit, so your R to T dot with your R to U all over the magnitude. So make sure you have it in terms of the vectors that are appropriate to what you're using. So here that would be 32 was our dot product over root 48 times root 32. And I'm waiting on somebody telling me what angle size therefore TRU is.
Miss, is it cos to the minus 1 of that angle?
Yeah, it's cos to, so I should have written that in, sorry. So we should write in there. Thank you, Kieran. Keeping me right. Right, so to work out TRU, we're going to write cos to the minus 1 of the 32 over root 48 times root 32. And if we do that correctly,
I got 35.2643.
so what would I round that to?
35.26.
Yeah, good. And remember, and put your degree sign in because it's your angle. Okay, so just make sure that you have got rounded, your unrounded, and then your rounded number when you do that. Okay, so now it's going to be your turn to go and practice.